Hello, everyone. Today, I'm going to talk about how we can deploy serverless architecture within AWS environments. So basically, what I'm going to do, I will be, okay. So yeah, I'll be deploying a serverless architecture on AWS, and it will be a purely a demo session. So I'm not going to talk about any kind of theory. So before you come to this session, I believe you have some basic knowledge about microservices. Just give me a second. Yeah, I believe you guys have some basic knowledge about microservices. I believe you know serverless architecture. And because I'm going to deal with different AWS services, which are basically serverless components. So like, for example, I will deal with Lambda functions. I will deal with SQS. I will be talking about S3 buckets. We will see how we can use ECS or container services like Elastic Container Service. I will also talk about DynamoDB, and I will also talk about API Gateway. So I'm not going to talk about any theoretical concepts. So I believe you guys have some basic knowledge about these few things. If you know these things, that would be good enough for me. So before I do my demo, I would like to give you what I'm going to build today. So this will be a serverless architecture that we want to deploy for an e-commerce applications. So how the architecture will look like, let's have a look. So let's say there is a visitor who recently visited a website, which is xyz.com or whatever. So they visit our e-commerce platform, and that guy is trying to purchase something. Maybe he's trying to purchase a pair of shoes, right? So once they add the shoes into the cart, after that, they will try to, or he will try to purchase the product, right? So he add the product in the cart. Now, what he's going to do, he will place the order now button, and he will provide the payment details as well, like credit card details. So those kind of details he will provide soon. So as soon as the guy will press the order button, what actually gonna happen? So as soon as they press the order now button, it will hit an API. And that API has been deployed in API Gateway, as you can see here. So in API Gateway, we have deployed an API endpoint. I mean, we will deploy an API endpoint. And basically what API Gateway does, API Gateway will work as a front door for our APIs. So what do I mean by front door? Because whenever anyone calls our APIs, and if the API resides inside the API Gateway, the API Gateway can protect our APIs. They can protect our APIs in many ways. For example, we want our APIs to be authenticated so that only authorized person can call us our APIs. So we can integrate some kind of authentications for our APIs. Also, API Gateway can help us to protect our APIs from DDoS attack. So, and in the API, so the guy hit our API endpoint, and the API behind the API, they actually using a microservices. So let's say we have a microservices called order processing microservice, and we deploy this microservice into a Lambda functions. So basically, whenever someone hits the API, they actually calling this order processing microservices, right? There's a misconceptions about microservices. People, or maybe the new freshers, they might think microservice always has to be Dockerized. It always has to be containerized. But that's not true. It could be any kind of programming language or programming model that we can use for a microservices. So that's what is here. So we have an order processing microservices which has been deployed into AWS Lambda, right? And so basically, let me start from the beginning. The user press the order now button, and as soon as they press the order now button, they are actually hitting the API, and there's a microservice behind the API. So what this microservice will do, it will take some details from the user. For example, what is the name of the user, payment details, the status of the payment. So they will do some processing, and then it will store the processing details into SQS, right? And then we have another microservice. I call it invoice generator. So we have another microservice running on an ECS as a container. And what this microservice does, or what this microservice will do, they will pick up that message from SQS. So as soon as the order processing service sends some details into SQS, the backend, the backend microservice, which is invoice generator, they will get the details from SQS, and they will process some data. And what they will do eventually, they will store. This microservice will generate an invoice, and it will store the invoice into S3 buckets. And at the same time, it will store some other details into DynamoDB table as well for future references. All right. And what's going to happen, we can stop it here, but what we will do as well. So as soon as the invoice has been stored in S3 bucket, there is another microservice. Which I deployed into Lambda as well. So as soon as any invoice has been generated, this microservice will get the invoice from storage buckets, and it will send the invoice to the user straight away. So that's the normal flow we're gonna implement today. It's not a very complex architecture, but if we want, we can make it more complex. All right. So let's jump into the actual demo. So basically, we're gonna in this lab, we're gonna provision an API gateway. We will provision a microservice in AWS Lambda. We will provision an SQS. We have S3 buckets, DynamoDB. We will provision ECS container as well, and we will also use simple email service for sending emails to visitors. But before I start the demo, I would like to give you another highlights. As you on that microservice, as you see, this are container of this microservice. So initially we will have three instances of these microservices, but you can see there is some dotted line. So what this dotted line means? So it means if demand goes up or demand goes down, the number of container instances will go up or down. So that what it means. We will implement an auto scaling here as well. All right. By the way, let me ask you quick questions. So as you see here, we have an order processing microservice, and it sends some data into SQS, and another microservice will pick up the data. So my question is, why not this microservice directly send the data to here? I mean, we could do that, but what's the problem with that? Why we need SQS? All right. So the reason we need SQS, because SQS will help us to decouple different microservices. So SQS basically decoupling these two microservices. So what do you mean by decoupling? I mean, if for any reasons this service stops working, maybe it's because of some bugs, or maybe I don't know, maybe because of other reasons, this service stops working. So if this microservice talks to this service directly, so and if this service goes down, that means this service will goes down as well. So in previous model or previous traditional architectures or legacy architectures, we have all the microservices tightly coupled. But the best practice is we should keep the microservices loosely coupled. And SQS can help us a lot to decouple different microservices. All right. So the whole architecture we are going to build today in maybe 50 minutes. So first of all, we will provision an S3 buckets. Then we will provision a DynamoDB table. Then we will provision these two Lambda, these two microservices in Lambda, then we will provision API gateways, then so on. So let's start. So first of all, we will deploy an S3 bucket. So you can see my AWS management console, right? So I will create, if you don't see my screen, just let me know. So I will create a bucket, let's say my lab, and make sure the name is globally unique, so I can provide some random names. I'm not going through all the details because I assume you guys have some basic concepts. So I will create a bucket in Sydney region. I leave everything as it is, and I will create the bucket. So it says, okay, just a second. Okay, I think bucket name cannot contain hyphen. Yeah. So I think I put a space, so I should not put a space. So I create a bucket. So the purpose of this bucket is we will the invoice for every customer will be stored in this bucket. So I just create a bucket. I will make a note. So just a second. Yep, I will make a note of my bucket. So this is my bucket, right? Then I will create a DynamoDB table. So I will go to DynamoDB. I will create a DynamoDB table. Create table. Let's give a name, my demo table. And the partition key, let's say the ID is the partition key, and that's what I want. And then I will create the table. So I create a table, my demo table, right? So I just make a note because I need these details later on. And if I go back to the architecture, if you can see, we need an S3 buckets, because in the S3 buckets, we will store the invoices. I mean, the invoice generator service will generate an invoice, and it will store the invoice in the bucket. And they also store some details in DynamoDB table as well. So this two table has been created, right? Now we will create SQS, and SQS is a queue service which will be needed by order processing service. So I will be creating an SQS. So I will go to SQS, simple queue service. At any point, if you cannot hear me or you cannot see my screen, just ping me or just raise your voice. All right, so I will create a queue. So there are two types of queues. It could be either standard or FIFO. If order is matter, then you can go for FIFO, which is first in, first out. But if delivery of the message doesn't matter, so you can go for standard SQS. So I will go for the standard one, my demo SQS. I leave everything as defaults. All right, so I leave everything as defaults. Then I will create the queue. So I just make a note. So this is my queue. So this is my DynamoDB table. And my SQS is this, right? We need these details later on. All right, so if I go back to here, so we have done SQS. And what next we're gonna do? Let's just give me a second. I have a GitHub repo which I will share with you later on. There are two microservices. One is called order processing, as you see here, and another microservice which is email service. So order processing microservice will process the order, and email service will send the email. So these are two microservices which has been already deployed into AWS Lambda. So if I go my Lambda functions, if I go my Lambda, I believe you guys have some familiarity with AWS Management Console. So I'm in Lambda functions now. So that two microservice has already been created. So, okay, and these are the two services which has already been created. One is order processing and another one is send email. So we have done these two microservices as well. Now what we're going to do, we will create an API gateway. All right, and the API, I mean, we will deploy an API endpoint in API gateway, and that endpoint will be used by this user. All right, so I will go to API gateway, and then I will create a REST API. I believe you are familiar with API gateway, more or less. All right, I will build a REST API. I will give a name, let's say my demo API. All right, I'm not going through all the details. I will try to make it as short as I can. My main purpose is to give you some hints about how to deploy a serverless architecture in AWS. So I have created the API. So just API has been created, but it's not done yet. I have to create a resource for our API. Like what would be the endpoint for checkout? So let's say this user is trying to checking out. So whenever they check out, that API will be called. So we will create an endpoint for our checkout service. So I will create a resource. Let's give a name. Let's say checkout. I will enable course, and then I will create the resource. So the resource has been created. It's not done yet because I need to create what method I will allow on that resource. So I will create a method, and in the method I can, because when they check out, eventually they will make a post request. So I will select a post method for checkout, and then I have to specify whenever the checkout endpoint has been called, what will be the backend. So in our case, if we look at the diagram, the backend would be the Lambda function where we deploy order processing service. So I will specify here, whenever this endpoint has been called, this Lambda function will be executed, and the Lambda function is called order processing. All right, so whenever this endpoint has been called, these Lambda functions will be executed. So I will save it. All right, and one last thing, that is I need to, there is a concept called proxy integrations. It's recommended to keep it unchecked, but to make our demo easier, I will check it. I mean, I will make sure it's checked. And what it does, it will pass the data that it gets from API to Lambda function as it is. It will pass all the data to Lambda functions. So that's what it's called. It's called proxy integrations, right? And by the way, if you have any questions, just put your comments on the chat box, and I will try to answer. Right. So that's all. And okay. So to make sure our API is actually working, we can also test our APIs. So there's an option for testing our APIs. If I do test, and then I can pass the payload. I have the payload in my GitHub repo. I will provide the repo link later on. So I'm just testing my API to make sure it's working or not. So I will press the test buttons, and let's see what is happening. So I'm getting a response. So basically, as soon as I press the test buttons, this Lambda function gets executed. And the logic has been written in this Lambda functions in order processing. So if I go here, I can see it processes some things, and it returns a response. And that's what we get here. So we can test our APIs before we deploy them. So our API is working perfectly. And now we can deploy it. And in AWS, we have to deploy the API in a stage. So if I press on deploy API, it will ask me to select a stage. So stage we can use for different environments. Like for example, we can have an API endpoint for testing purpose. We can have an API endpoint for production, for development. So we can define which stage we want the API for. So I will create a stage, and let's give a name to the stage. Let's say production. So this API will be or not production. Let's make it dev. So this API endpoint will be deployed into dev environment. So as soon as I click deploy, the API has been deployed, and you will be given the API endpoint. So this is the base URL of the API. So previously I tested the API from AWS Management Console, but now I will test the API from a Postman, right? So let's copy the API endpoint. And also I will make a note of this endpoint. I might need it later on. So, all right, so I will go to Postman. Where is my Postman? Okay. Postman is coming. Oh, I got it, Postman, not this one. Just give me a second. Postman is loading. All right, so I will call the API from Postman. So this is the base URL of our API, but we need to specify the resource name, which was checkout. And also I will pass the JSON parameter. So this is the parameter we're gonna pass. So as soon as I press send, I hope I will get a response. So I get a response, right? So what it does, as soon as I call the API, this Lambda function gets triggered, and it process the order, and it sends some details into SQS bucket. And the other microservice called invoice generator, they will pick the message later on from the SQS. So we can test our SQS as well to make sure our API or Lambda function, this Lambda function is actually sending something into SQS. So if I go to SQS, just give me a sec. If I go to SQS, where is SQS? Okay, this is SQS. So if I can test, I can make sure my SQS is actually receiving some data. So this is the SQS I have created, and I will try to pull some message. If I pull message, I will see I can receive some data shortly. It might take few minutes, just give me a sec. All right, there's one thing I forget to specify. I forget to mention. In the Lambda functions for order processing, I need to provide some. I need to update some variables. For example, I need to update these variables with the SQS name that we just created, and that's why we have the reference here. So this is the SQS I just created, and I have to specify it in my order processing Lambda functions. So I save it. I think this is the only thing I want. I deploy it. All right, now let's make another call. So let's call it, okay. So I'm getting a response, and let's see the SQS. Let's pull the message again, and let's see if I get anything. See, I received a message in SQS. So I can test whether my API has been successfully executed or not. I can see some data in SQS. That means this part is working perfectly. API gateway is working, Lambda is working, SQS is working fine so far. All right, so before I jump into ECS, I would like to tell you one more thing. I'm not sure if you have ever used Lambda functions, but let me tell you a few things about Lambda functions. Because if I look at the diagram, we can see AWS Lambda is talking to SQS. So by default, Lambda functions cannot talk to any other services unless we give them some permissions, right? So if I go to my Lambda functions, and there is an options for giving more permissions. So whenever we create a Lambda functions, it automatically creates a role, and in the role, I can tell what kind of permissions I want to give to the Lambda functions, right? So if you look at, so this roles is assigned to the Lambda, and I'm giving it SQS full access permissions. So that means this Lambda is able to talk to SQS. Otherwise, by default, by nature, Lambda cannot talk to other services unless you explicitly define some permissions. So this is one important thing. Whenever you create Lambda functions, you have to make sure you give right permissions to the Lambda functions so that it can talk to Lambda, and it can talk to other services. And second thing is, All right. Second thing is, if I go to general configurations, the important thing, by default, when you create a Lambda functions, it can execute only for 3 seconds. But most of the cases, we want our Lambda to be executed for longer period of time, maybe for 5 minutes max, or maybe maximum AWS allow Lambda can have up to 15 minutes. So that's why Lambda is for. Lambda is not for long living programming concepts. It's for short living code executions. There's another Lambda functions for email services. I need to also update the Lambda function as well. So this is email service. I need to update a few things here. Just give me a second. I need to update DynamoDB table name. So I have the DynamoDB table. If I go here, so this is my DynamoDB table. All right. And what else? Just give a second. I see boilerplate is 3. Just give me a second. Okay. Okay. So I just need to update the DynamoDB table name. That's all. All right. So I'm going back to my architecture. So now the most interesting part, and might be the most complex one, is to integrate ECS, this one. So I believe everyone has heard about Kubernetes. So ECS, or Elastic Container Service, is an alternate solution to Kubernetes, but it's an AWS offering. It's designed by AWS, and AWS, because it's their product, AWS always recommend us to use ECS because it's their product. But I have worked with Kubernetes, I have worked with ECS. If you know Kubernetes, you will get to know ECS very well. They're very similar to Kubernetes, but we will be deploying this one now. But before I create the Kubernetes ECS clusters, I have to create the invoice generator services, right? So in the repo, I will provide the repo link later on, but so basically, what I'm going to do now, I'm going to build an image for this invoice generator, and then I will push this image to Elastic Container Registry, or ECR, and then ECS service, or this container, will use that image from ECR. So that's what I'm going to do now. So I'm going to my shell script, or git bash command line. And then just give me a second. Sorry, you cannot see my screen, I believe. So yeah, you can see my screen. All right. So I will log into my VM. Just give me a second. So if I go to microservice, I will provide you the link for this GitHub repo. So microservice, then, so yeah. So this is my folder where I have code for invoice generator microservice. If I see here, you can see there is a Docker file which will build the image. So I will build that image now. But okay, so I believe more or less all of you have some knowledge about Docker. So I will build the microservice locally first, then I will deploy them into ECR. So sudo docker build -t, then give a name, let's say my demo image. All right. So the Docker has been built because I already built previously, so it's like take less time. It took less time. All right. So I build the image. Now what we're gonna do? We will create a repo container repository into our AWS account, right? I can show you how we can create a repo in container registry from the management console. Like if I go to ECR, so ECR is similar to Docker Hub. So we can create a private repo, and we can deploy our microservices as an image into that repo. So I can create a repo here, but I would love to show you some CLI magic, right? So I will create a repo with CLI, and there's a command for that. It's called AWS then ECR, which means Elastic Container Registry, then create repository. Then I will give a name, repository name, my demo image. Okay, my demo is my demo ECR image, right? So I just create a repository. It has been created, and I can verify that. I can verify if I refresh the page, you would see there is an image already been created. And the image I built a few minutes back in my local machine, I will deploy that image into this repository. But before do that, I need to do a few things. First of all, I need to log into this private repository. I think if you work with Docker Hub, and if you want to deploy any image to Docker Hub, you need to log into your Docker Hub with Docker login command. The same thing goes for this one as well. We have to type Docker login command to get access or to log into this repo, but command is a little bit different. So what we want, this is the repo. I have the command here. You can see I will execute this command, but I need to replace few things. I need to replace the account ID with the real one and the region. So I copied the whole command, and then if I go here, I will run it, but it will not run. It will not run because I need to provide the right details. So I need to provide the account ID of my AWS account, and then I can get it from here. This is my account number, and I need to also specify the region. My region is Sydney region, which is AP Southeast 2. So this is my region, and that's how you can log into ECR repository. And if I press enter, you can see I got login succeeded. So that means I have successfully logged into my newly created repository. Now I will push my image that I created locally into that repository, right? And how we can do that. But before we can do that, we need to retag our image name, because the image we created was called my demo image. But if we want to deploy anything on ECR, it has to be in a specific format. The format is so let's go back. So I will type sudo docker tag, and I will retag this image. Sorry, I will retag this image with something like this. I will copy the whole URL. So the image name has to be in that format, right? I just copy it and I paste it here. So I will retag the previously created image into this one, and I will press enter. And you can see it. If I do sudo docker images, I can see my image here. So this is the image I just created. All right. So now I will push this image directly to our repository. I will copy the whole image URI. Then I will type sudo docker push and the image URI, paste, and press enter. So the repo we just created is now deployed into our container registry. It will be deployed shortly. We can verify. All right. The best practice is I created the image manually with a docker build command. Then I log into ECR, then I deploy them into ECR. So this is not the right way to do that. In production grade applications, everything has to be done through some kind of CI/CD pipeline. We should not do anything manually. But because I don't have the pipeline, so I thought it's better to give you the demo from scratch. All right. So that's how we can push. We can push the image into Docker registry, right? But I want to show you something else as well. if I go back to so basically, if I go back to the line, if I go back to message.py, I need to replace few things which I totally forgot. I'm sorry for that. So I need to replace the queue name, which was my demo SQS, right? I need to give the bucket name as well that we created. I totally forget. Okay, bucket name, and then I will give the DynamoDB table name. This one, DynamoDB table. So these three things I need to update into message.py because this microservice is for this one. Because whenever this microservice runs, it needs to talk to S3 buckets, it needs to talk to DynamoDB table. That's why we need to give, we need to specify the resource name properly. So I just updated the message.py, and sorry for that, I need to rebuild the image. So just give me a second. I will rebuild the image. Okay, image has been rebuilt. Anyways, guys, if you have any questions, just I would love to see some voice. All right, the image has been built, and then I will retag the image again. So this is the retagging my demo image. Okay, so I retag the image again, and then I will push it back to repo, right? So, yep, the image has been pushed. We can verify that. If I go back to the repo, we can see that an image has just been pushed. So we need this image. So I will copy the image URI again, because at this stage, we will deploy an ECS cluster, and we will deploy the image into the cluster, right? And we will also see how to integrate auto-scaling as well. So I will go to ECS service. First thing first, I need to create a cluster. By the way, ECS has two kinds of offerings. We can use, because I'm talking about serverless, so ECS has a serverless offering, what they call Fargate, and they have non-Fargate offering as well, which is not serverless. So I'm going to use ECS Fargate. So this is the one thing. We don't want any EC2 instance. So in Fargate, we don't need to think about any servers. So I will create a Fargate cluster, and there will not be any servers. So I will create the servers. It's very straightforward. My demo lab, I don't want to create a VPC, so I will create. So cluster has been created. Now, two things. To deploy, because we are in this stage, we will deploy invoice generator service into ECS cluster. And there are two things. First thing, we need to create a task definitions, and then we have to create a service. So what is task definitions? If you come from Kubernetes background, there is a concept called pod. So pod is similar to task definitions. In Kubernetes pods, we define how the pod will look like the resource or limits, or we can define what image the pod will use. So we can define them in a pod definition files. Similarly, in ECS, they call it task definition. And in the task definitions, we can define what the pod will look like what image it will use, and so many other things we can specify in task definitions. So this is the source of truth. So I will create a task definitions. So new task definitions, I will create a Fargate task definitions. So in ECS, whenever we say Fargate, it means serverless. There is no EC2 involved. All right. So I will create a Fargate task, a task for Fargate. Then I will give a name, my demo task. I will define a role. This is very important. because your task or your service might need to talk to other AWS services. So I already created an IAM role, which gives all the permissions, so that whenever task, basically whenever this task, this container will run, it will talk to SQS, it will talk to S3 buckets, it will talk to DynamoDB table. So the task or the container should have that permissions, right? So that's what I'm going to do. So I already created a role, and network mode would be AWS VPC. I can specify the platform, which is Linux. Similarly, there's another thing, task execution role. They're quite similar, but we also need a task execution roles so that container can talk to ECR. Because if I go back to here, the container then needs to grab the image from ECR. So in this role, we can define that this task can talk to ECR. So these two roles already pre-created, so I'm not going to do that anymore. So I define the task roles, I define the task size. It's similar to pod, Kubernetes pod. They also have option to specify the resource restrictions. Same thing we can do for ECS task definition as well. So what I'm saying, we can specify how much memory or how much vCPU that container can consume. So I can specify that. So let's say I want the task to have maximum 1 GB of memory, and vCPU has to be let's say 0.5 vCPU. So there's a relation, like if I choose 1 GB memory for task, I cannot choose 2 vCPU. It will give you error. So there should be some kind of relation between memory and vCPU. Like, because my memory is 1 GB memory, I think I cannot choose 1 vCPU. I can choose maximum 0.5 vCPU, right? So these are the few things I need to specify for the task definitions. And another important thing is I also need to specify the container. So task definition, as I said before, is a source of truth. So in the task definitions, I will specify what image this task will use. So we already created an image. So this is the image. I will pick the image URI and I will copy and paste here. So behind the scene, this is the microservice for inverse generator, right? So I give a name, my image, whatever. That's it. And I don't go through all of them. So I will press add. So the container definition has been defined. Anyways, there are enormous number of configurations that we can specify. I just leave everything default. And then the task definition has been created, right? And then if you come from Kubernetes background, you might know services, right? Or not services, deployments. So in Kubernetes, in deployment manifest file, we can specify how many pods we want to be running. Similarly, in ECS as well, task definition doesn't make any sense by itself. We have to create a service. So if I go to our created cluster, and now I will create a service, and in the service I will specify how many instances of the container we want to be running, right? So that's what we do with services. So I will, for services as well, I will specify it will be Fargate type, main serverless. I choose the task definition that I just created, and every task definition has a version. Whenever we update the task definition, it creates another version, right? So we only have one version. I will choose that. Rest of them I can leave as it is. I need to give a name. Let's say my demo service, and how many instances we want to be running. Let's say it's 3. And then I will go next. I will choose the VPC where I want the container to be running, and I already have a VPC, and I choose a subnet, which is public subnets, and also I specify the security group. Security groups might be crucial if your task talk to other services or other even internally, if they talk to each other components of other VPC, so security group can help us. Security group is kind of defining firewall rules. So I will, rather than creating a new one, I will select an existing security group which gives all the permissions. So it's better to use the default one. But in production, we should stop using default security group, because default security groups give you all the permissions. So I will choose default anyways. And then rest I can leave as it is. All right, in the next step, I will configure auto scaling later on. All right, I will leave it for now, and I will create the service. Right, so just give me a second. The service has been created. So if I go back to my design, so pretty much everything I have done apart from this one. So we just created a container cluster, and we deploy our container in the cluster, and there we also define how many instances of the how many instances of the service we want to be running. So we define 3. That means initially it will initialize 3 containers for these services. And if I go back to the AWS Management Console again, if I refresh the page, can you see? So we have 3 containers running. One is still in pending state, but it will be in running state soon. So I have deployed the containers or microservice in the clusters, but we haven't defined the auto scaling yet. How can we do that? So we have to define the auto scaling now. So to do that, so basically the auto scaling will happen based on number of messages that have in SQS. So if the number of message in SQS increase, the number of instance or number of tasks, they call it task, number of tasks in the ECS cluster will also be increased. So let's go to CloudWatch alarm. And I will create an alarm, right? So I go to all alarm, then create alarm. I will select the matrix. Matrix means based on what criteria we will increase the number of tasks. And the criteria is number of message available in SQS. So I will select that matrix. So select matrix, then I will choose SQS service. Then I will choose Q matrix. And there are so many matrix we can see. I think this is the matrix. If I search here, so that's what we want. This is our, so we will increase the number of tasks based on these matrices for this SQS. So if the number of available message on that SQS go up or down, and based on that criteria, we will increase the number of instances in our cluster. So this is the matrix we want. So select the matrix. I will define the criteria now. What is the criteria? So in criteria, it could be, so what we want number of message to be available in 1 minute. So I will select some. So number of available message in this SQS for 1 minute. If it's greater than, let's make a more small number. If it's more than 10, then we will increase the number of tasks. So I will select next. Then I don't want any notifications. I will leave everything as it is. So this is high scaling. That means this is the policy to define how we want our number of instances to be increased. So I just create a scaling policy. I will attach it to ECS instance later on. Then create alarm. I created alarm for high scaling, and I will create an alarm for low scaling. So if the number of available message in SQS goes down, what's going to happen? So I will do the same thing. I will choose SQS Q matrix. I will select. It's visible. Okay, so this is the one we want. So this is the SQS we want. select matrix, similar thing. We are going to do it for low scaling. So if number of messages goes down, so if number of message for 1 minute goes down below 10. So this is another policy if we want to scale down. So I remove the notifications. I don't want any notifications. Let's say low scaling. So I define the scaling policy. Now we will attach the scaling policy in the cluster, right? So I will go back to my ECS instance. Let's see, something's wrong anyways. So what we will do, if I go back to my services, this is the service. And then there's an option for auto scaling. We can update it. We can update the service. If I go next step, there's an option for auto scaling. So previously it was disabled. Now I will enable the scaling. So I will choose this one and I will define minimum number of tasks. Let's say 3. I will define maximum number of tasks. Let's say 10. So if we get more than 10 messages in the SQS, the maximum number of tasks will be 10, right? And then if we want, we can use some roles as well. And then we will define the policy that we created. So the policy we created called high scaling. So we will attach both scaling here. So if it's high, if the load is high, we will add, let's say, we will add 5 instances or 5 tasks, right? If it's more than 10. So I will save it. I give a name. Let's say high. Similarly, so this is the policy for high. We need to specify the policy for low as well. So this is the policy for low. I will choose the step scaling. I will choose our lows policy, right? So that's how we can define policy for our services. All right. Finally, I would like to tell you one thing. If we look at the architecture, so this Lambda gets triggered whenever an invoice has been generated and stored into this S3 buckets, right? So this thing has not been integrated yet. We have the email service, we have the storage bucket for storing the invoices, but we haven't configured the event yet, like when this Lambda will trigger. We need to configure it. So to do that, we will go to the S3 buckets. So let's go to S3 buckets, and we have to create an event. So basically what event says what's going to happen whenever a specific thing happens. So what does this event says? Whenever a specific event happens within this S3 bucket, I want that Lambda functions to be get triggered. So that's what I'm going to do now. So I will go to the S3 buckets, and then I will go to properties tab, and in the very bottom there is an option for event notifications. I will create an event, and then let's give a dummy name, like event dummy event, and I want this event to be for all the objects created within this S3 buckets, and I want that a Lambda function will be triggered only when any new objects has been created within this bucket. So I will check all object create events, right? And then the last thing I need to do, I need to specify which Lambda functions to be triggered whenever an object has been created within this bucket. So if I look at the architecture, so I want this email service to be invoked whenever an invoice has been generated within this bucket. So the email service that we have deployed is called send email function. So this is the functions to be triggered. So I just need the function ARN. I copied it and I paste it here in Lambda function ARN. That's it. So what I have done, I will save it. And so what I have done, I configure an event notifications. And what this event notification will do, it will trigger these Lambda functions whenever an object has been created in this bucket. So if I go the design again, so that's what we have done. We have S3 buckets. We created the events which will trigger this microservice, right? So that's how we can also implement event-based architectures within our design. So let's start from the beginning, what we have done so far. So let's say a user has just visited an e-commerce website called xyz.com, and then they put some items in the cart, and now they're ready to pay for the items. So the user might have provided some payment details, and then at the end, the customer will press the order now button. And as soon as the order now button has been pressed, what's going to happen? The user will hit an API, which is deployed in API gateway, and that API will eventually call a microservice called order processing, which is deployed into Lambda. That microservice will process the order details, and it will store some data in SQS. And then there is another microservice running in ECS clusters. I call them invoice generator. So what this invoice generator service do, it will get the details from SQS, and it will process the data that they get from SQS and generate an invoice. And that invoice generator service will store the invoice into an S3 bucket. And at the same time, the service running on ECS cluster also put the relevant metadata into DynamoDB table, which is a NoSQL database engine, right? We have another Lambda functions or microservice that running on Lambda. I call them email service. So what this email service will do, it will pick up the invoice from S3 buckets. I mean, whenever the invoice has been generated and stored into S3 bucket, Lambda function will pick that up, and it will send that invoice back to the customer via simple email service. So simple email service is another AWS serverless offering. So that's what I have done so far. It's a very basic and simple architecture. If we want, we can make them complex, more complex. We can integrate other AWS offering as well. For example, we can use Cognito here. This is another AWS offering. We can use Cognito in front of API gateway, so that every API came through API gateway, it will be authenticated via Cognito, which is an identity provider. We can do many other things. We can use AWS CloudWatch logs for storing logs for our services. By default, Lambda functions is automatically integrated with CloudWatch logs. So whatever logs Lambda generates, it goes to CloudWatch logs straight away. We don't need to worry about anything. Similarly, we have clusters. We have ECS tasks running on ECS cluster, and they also integrated with CloudWatch logs automatically. So whatever logs these tasks generate, those logs will be stored into CloudWatch logs.
So thank you, first of all. And I have few questions. So suppose we use here ECS, right? So is it possible to proceed the whole application without ECS? We just need to, if I want to trigger another Lambda function from our SQS, is it possible?
Yeah, it is possible. It is completely doable. You can replace the whole thing with Lambda as well. But I want to show you how, because I was trying to use different AWS services. So I have already 2 Lambda functions. So I thought, let's use ECS. But Lambda could be a good option. You can use Lambda as well. But
okay, so if I use ECS, it will be most cost. If I use Lambda, then it will be most cost effective, right? Compared to ECS.
Yes, it will be cost effective, but Lambda has some downtime and some problem with Lambda. For example, it cannot be run for a long time. If your application executes for longer than 15 minutes, Lambda might not be an option. Second thing is, most of the microservices are based on Docker based, right? Though we can run Docker in Lambda as well, but if we want to run any kind of containers, ECS or Kubernetes is the right options. So we should use Lambda for small short running applications. Yes.
Oh, I see.
And also ECS,
So
ECS would be a little bit costly. Yeah. Comparative to
so suppose I have 5 microservices and I want to separate them in different ECS, then I should use ECS. And if I have a small task that should be done, that would be done by Lambda, right?
Yeah. Basically, Lambda we use for automations, kind of batch processing. For short-living applications, we can use Lambda. Yeah. That's right. But I was just trying to pick up different AWS services from different places. So I have example from Lambda. So I thought let's give some examples from ECS, right? So that was the purpose. And any more question, guys? Thank you, Shahid, for a question.
Okay, may I ask you a few other questions?
Yep.
Okay, so if I want to at the authentication and authorization process in our this architecture, where should I put these services before AWS Lambda, or it should be in AWS API Gateway?
All right. So for authentication, what you can do, you can directly integrate API Gateway with Cognito or with authentication. If I go back to the API Gateway, if I go back to API Gateway in method, you can see there's an option for authentications. So I can define authentication as well. I can define if the API requires any API keys. So there's so many settings we can define in the API Gateway, but we cannot directly integrate authentication with AWS Lambda. But what we can do, because Lambda, no one can execute Lambda from outside. Either you can access into AWS, then you can execute AWS Lambda. You cannot execute AWS Lambda from outside. To execute AWS Lambda, you need an API Gateway. And API Gateway will be authenticated via Cognito, and then API Gateway can call the AWS Lambda. So that's how you can authenticate. You can authenticate Lambda through API Gateway. Right. Similar thing goes for SQS as well. You cannot directly access SQS from outside. You need some kind of middleware in between. So yeah, that could be my answer. Another thing is you can deploy AWS Lambda inside a VPC, so that only whoever within that VPC, they can access that AWS Lambda. Also, you can whenever you create a storage bucket, you have to make it private for security reasons, unless you need public access. So, for example, invoice is a confidential data. So it has to be resided in a private bucket. So there are so many security best practices that we should follow. I think that's the answer for your questions, Shahid.
Yeah.
Any other questions,
Yes,
please?
thank you. No, I don't have any question. Will you going to share the slide, right? If you already recorded.
I will share the slides. I will share the recording as well. And there's a question from Tanvir. What do you mean by that? Like with EKS or AKS? What does it mean? Can you please elaborate, Tanvir? All right. I think the question was I'm not sure what does the question mean.
Sorry. My question was, are you going to make any other session in Azure or AWS?
Yeah, I might. It's a good question. I might create another session for EKS. Not sure about EKS, but I have so many things to share for EKS as well. Yeah, that's the answer for your question. And there's a question for Thomas. I think Thomas is from my university. Is that right, Thomas?
Yeah. So Asif, I have one question actually. Can I do it right now?
Yeah, sure.
Yeah. So one thing is that in S3, Amazon S3, so is kind of cache, right?
No, it's not
So,
a cache.
Yeah. So my question is that why don't we use cache here, and what's the facility of using the storage here, S3 storage?
Okay, so your question was, why don't we use caching service rather than S3?
Yeah.
That was your question, right?
All
right. So S3 is kind of a storage solutions for long run. S3 is a durable storage solutions. So for example, if you want something, some assets, some files, images, videos to be stored for long run, then you have to store them in S3. If you store them in caching services, and if the server goes down or if anything happens, the cache will be lost. So we will not store any invoice on the caching for sure, because we need invoice for long time. Right? Like maybe after 3 years, customer might want to download their invoice as well. So we need some durable solutions. So,
but we have DynamoDB here.
Yeah, yes, in DynamoDB, basically in S3's bucket, we store the PDF files, right? We cannot store PDF file in DynamoDB table. In DynamoDB table, the application, this service stores some basic data into DynamoDB table, but in S3 bucket, they store the invoice. It's an example. If we want anything that we want to be stored for long run, maybe for 5 years to 10 years, then, and if it's an image, videos, we cannot store them in DynamoDB table. So, and S3 is one of the best options for storing any kind of static objects. There could be another options. We can store the data into DynamoDB table, and then whenever customer asks for any invoice, there's another service. The invoice generator service will pick the details from DynamoDB table, and it will generate the invoice. So it could be another option as well. Depending on business cases, business requirements, you are right as well. Like we can completely ignore S3, and we can store everything in DynamoDB table. And whenever we request for any invoice, the invoice generator will generate the invoice from DynamoDB table. That also possible. That's nothing wrong with that. But there are many options. I'm not saying this is the best options. There are many options that we can go for.
Actually, my understanding was, so you were storing the PDF file in S3, but metadata in DynamoDB, right?
Yeah.
But next question is, when customer will get the email, will receive the email, so that AWS Lambda in email portion, so it will hit the storage again to get the PDF and then send the email, right?
Exactly.
So how about SQS? We can't use SQS here instead of AWS Lambda?
You mean here?
Yeah.
You said we can use SQS, right?
Yeah.
No, we cannot use SQS. The reason is SQS just store the data. It cannot process anything. It cannot execute any logic. So if we use SQS here, like let's remove it. If we use SQS here, it doesn't make sense because SQS cannot process anything. It can only store. Right? Did you get your answer, Thomas?
Yeah, I got it. Thank you.
I love to hear answer from you guys, like because even I learned so many things from who I teach.